In this episode, we'll be taking a look at different dummy load models. These are all purchased either from eBay or from Banggood, so they're easy to get and relatively inexpensive. I just wanted to show them together in this video and make a bit of a comparison just to help you understand the differences between these models so that you can choose the model that will fit your needs best. I have 5 dummy loads in total, starting from $5 a piece up to $20 a piece. There might be slight variations of these available for purchase. Some might come configured for different maximum power dissipation, some might have an enclosure, but those are all details that you can figure out on your own. Today I'm just going to point out the major differences and features of each one of these dummy loads. So we're going to start with this one called the ZB2L3. This dummy load gets shipped with a 5 watt 7.5 ohm resistor, but they recommend using a 50 watt resistor mounted on a heatsink for better heat dissipation. This model doesn't quite offer adjustable discharge current because the current is set through this dummy load resistor. So you kind of need to have different value resistors to get different discharge currents, and on top of that the current will vary with the voltage, so it's not quite a constant current dummy load. That is because this dummy load simply switches the resistor in parallel with the battery under test and measures the current that passes through for recording and calculating the total capacity. With the supplied 7.5 ohm resistor at 4.2 volts, you get about 560 milliamps discharge current, and with just a 5 watt rated resistor, it's going to get hot quite quickly, so you definitely need a proper aluminum shell resistor strapped to a heatsink. This dummy load has some error detection built in. It will detect if the battery voltage is above the 15 volts, the maximum allowed input, if the discharge current is lower than the set current, if the battery voltage is lower than the cutoff voltage, or if the current goes over the maximum 3 amps. So this thing is cheap but doesn't offer you that many features. It's good for small tests, but for someone who plans to test more batteries, I would recommend going for something better. There is also another resistive dummy load model on Banggood. Here is a picture of it. I think it's pretty similar to this one. It does the same thing by switching the resistor across the battery while measuring and logging the current. I guess the advantage of these resistive loads is that you can get down to small currents under 100 milliamps. However, this second one is very limited with just 5 volts maximum discharge voltage and no adjustable cutoff voltage. Anyway, there will be a link to both of these in the description below. Our next dummy load is a classical analog one, but that might be exactly what you need because it's simple, reliable and gets the job done without too many features. It's built around an LM393 dual comparator and an LM258 dual op-amp, together with an IRFP 250N 30 amps 200 volts capable MOSFET. It also has a TL431 as a voltage reference for the input of the comparator, so that should give it some stability. It uses 2 shunt resistors. They are paralleled, probably for increased current capability, and for the dummy load actual input we have these chunky spade connectors that look like they could handle quite a bit of current. We also get some connectors on this dummy load. J1 right here, if I'm not mistaken, it's a front panel voltmeter connector. You basically get the V plus input, V minus input, and plus 12 volts on this header. And you also get some pads on the back for, I think right here, for connecting the V minus of the load to the analog ground of the board. And we've seen that being done on other dummy loads as well. Next we have J2, which is a JST fan connector, which simply brings 12 volt power to a pin header for connecting a cooling fan. J3 is our 12 volts power supply DC input, and for that we get this cable. And J4 is our potentiometer header, and we get another cable for that connector. It works with something between 5 and 20K. I would recommend using a 10-turn pot here to get a finer adjustment on the current. I think I might build this one into a nice enclosure with a nice big heatsink and cooling fan, and use it for sinking heavy currents. In fact, I will do a separate video on how I build a complete dummy load with a panel meter using this dummy load board. So I would recommend getting this one if you don't need fancy features and you just want to sink heavy currents. This will do it reliably, and for this price under $8 you can't go wrong. Get yourself one of these. This next dummy load, it's called ZB206 Plus. It's a bit more interesting, though I feel it's kind of limited in terms of maximum discharge voltage and power, but it's probably designed for discharging 18650 cells or just lithium cells. It has digital control, so that gives us a bit more features. The discharge voltage can be between 1 and 8.5 volts, and the cutoff voltage can be adjusted in 100 millivolts increments between 1 volts and 6 volts. So that covers 1 up to 2 lithium cells in series. We see it has these cutouts around the display area, and I'm guessing they designed it this way so that you can cut away this display section and mount it on a front panel, and then just use these vias that you will get one on each side and connect with wires to the front panel. So that's a nice feature built into the design. It also features automatic battery type detection, so it will automatically adjust the cutoff voltage depending on the battery you connect, and it does that looking at the voltage of the battery. So you're supposed to connect a fully charged battery, and the fully charged lithium cells usually have a quite precise voltage, so it uses that to detect the type of cell you've connected. Same as with the other ZHIYU dummy loads, you can turn on or off these features at startup by holding the SK button while applying power, and you enter the configuration menu. If you want to use the battery internal resistance test, you need to hold the S- key while applying power. The display will show R000, and if you connect a battery using 4-wire mode, it will measure and display its internal resistance. If you press SK button while in this mode, the display will toggle between the battery internal resistance and the battery voltage. It features a bunch of error codes similar to other ZHIYU dummy loads. It detects if the battery voltage is too high or if the battery voltage is below the cutoff voltage, if the current is below the set discharge current. It detects if the power transistor is damaged, and I'm curious to know how it does that. It detects if the total discharge power is greater than 12 watts, but that feature can be turned off to allow you to install a bigger heatsink and cooling fan. That will effectively increase the power dissipation capability above 12 watts, and it will also detect if the 12 volts DC input is out of range. One thing I noticed during testing with this dummy load, even if the power dissipation is under the rated 12 watts, this small heatsink gets very hot in under a minute, and it looks and feels like the magic smoke will escape soon from the power transistor. In fact, I think anything above 5 watts is too much for this very small heatsink, and it will reach 100 degrees in no time. Also, there is no temperature sensor on the board to detect when the temperature rises too much, so I would recommend upgrading this to a slightly bigger heatsink and a cooling fan, because there are a couple of points on this PCB designed to connect a 12 volts fan. You will have to take the positive from the center pin of the DC barrel jack and the negative from this point right here marked F-, which is transistor controlled from the onboard microcontroller. Even if there is no temperature sensor on this dummy load, they have implemented a feature in the menu where you set a threshold in watts, and when the power exceeds that threshold, the fan will be turned on. Otherwise, it will be kept off. If using the supplied pads on the PCB, you will benefit from that function. This threshold can be adjusted between 0, meaning fan is always on, and 9 watts in 1 watt increments, meaning when the dummy load exceeds 9 watts, the fan will turn on if you set that figure for 9. This dummy load also has a calibration menu that you can access by pressing both S- and S+ at the same time while applying power. And then within 2 seconds, release those two and press the escape button as you hear the buzzer. Or at least that's what I understand from the rather Chinglish instructions that can be found on some eBay or AliExpress listings. But we won't go through that today because I'm sure this will already be quite a lengthy video. So this thing seems to offer the most comprehensive set of features for the price. I like it, it's a nice dummy load, but it is limited to a maximum 8.5 volt discharge voltage, so it's up to your particular needs to decide if this will work for you or not. It basically is designed for working just with up to 2 lithium cells. It's not designed to test power supplies or anything like that. The next dummy load that we're looking at, it doesn't really have any name marked on the PCB, but I'm just going to call it eLoad USB. This dummy load is the only one out of the bunch that offers a PC app and connectivity. This might be a good selling point and a very important feature for some of you. Let me tell you about its specs. It works of 5 volts micro USB connection, but you do get additional pin headers for power. It's digitally controlled. I believe it uses an STM8S microcontroller. It has this nice LCD display. Let me show you how this one looks like, how the LCD looks like when it's powered on. It has a nice LCD display with good contrast. This thing can do 0 to 15 volts with 1 millivolt resolution on the cutoff voltage. So on that aspect, it's the best out of the bunch. It can do 0.1 amps to 3 amps with 10 milliamps resolution. Too bad it doesn't go below 100 milliamps. I think 50 milliamps is also a useful value for discharging smaller capacity batteries. This thing can measure internal battery resistance using 4-wire mode. You can set the backlight on or off through the menu. It has a fan connection for 5 volts, which is controlled through the menu as a threshold. So if you set the menu option for 10 watts, the fan will start when the dissipated power is over 10 watts. But there is no temperature control, and also I didn't see any thermistor on the board, so there is no temperature protection. I think this is an important feature that shouldn't be missing from a dummy load. It's not that expensive to add a thermistor on this board. There is a menu option called temperature, but it doesn't appear to do anything, maybe just showing the internal temperature from the STM8 microcontroller. I don't know. I think the designers of this dummy load should have implemented a thermistor and a temperature protection, because it's really easy to do that, and it's a powerful protection function that every dummy load should have. This one has a slightly better Chinglish manual, probably thanks to the effort of the Banggood customer service. I will post a link in the description. It's probably the most complex dummy load in terms of settings, options, menus out of the bunch showed here today. So the user manual, even in Chinglish, will be very appreciated when getting to know this device. It also has a calibration function described in the user manual, but we're not going to do that in this video because that takes time. Now, moving on, let me tell you about the serial interface and the associated PC app. I will post a link in the description that you can use to download the Windows app for this dummy load. This thing basically connects the microcontroller serial interface TX and RX through the data lines of this micro USB connector, which then go through this dongle, which is supplied in the package, and the dongle connects to the USB port of your computer. Inside this dongle is just a PL2303 USB to serial converter. Let me open it and show you how it looks inside. So as you can see, this is just a nicely packaged USB to serial converter. I kind of like the idea of routing the RX and TX serial lines through the D+ and D- signals of a USB cable, because you can place this, you can connect this through just a regular USB cable. But actually I think there is a clone of the PL2303, because if you try to install the latest version of the driver from Prolific, it will not work. At least on my computer on Windows 7. I think they've done something similar to what FTDI did with their driver, and they're blocking non-genuine chips from working. Also, the driver supplied in the zip archive together with the DummyLoad app doesn't work at all. It fails every time I try to run it on my Windows 7 64-bit machine. So what I had to do is search for an older driver, and I found a version from 2009. Just Google this string that I will post on screen. It's version 1.013 from 2009, and install this version. This is what got it working on my machine running Windows 7 64-bit. After installing the driver, connect the dongle, the actual DummyLoad as well, and run the app by double clicking on eLoad u15.bat. This will present you with a rather intuitive, simple interface, but the problem is the language. The app is in Chinese, so all buttons and messages are in Chinese. There are all sorts of files in the zip archive, maybe even source files. But it might be possible for someone who knows its way around to translate this app. That would be very helpful. Also, someone which has the skills and the time needed could also write a new app from scratch just by sniffing the protocol, because there are just a few buttons and commands that the interface sends to the DummyLoad, and there's probably a custom data string that is being sent constantly every second, probably from the DummyLoad to the PC with all the measured values. Anyway, let me tell you what you can do with this app. First, you need to select your COM port and click this button right here, which just means connect. Next, you can set the cutoff voltage and the discharge current right here, and you can click start on this button, which becomes a pause button after being started, and the button next to it is the stop button. The graph on the right will automatically update as the time passes. You'll get a red line for the battery voltage, and I think a green light for the power. Also, in the small text box you will see all the data points that have been recorded, and the meters on top will show live measurement values. These two buttons, the one on the left means save data and the other one means read waveform. So I think you can save a text file with all the measurement points recorded with the save data button, and you can read back the same text file with the read waveform button. These other two buttons and fields are related to the constant current source function, which I don't really understand what it does, and I haven't had enough time to play with the function. So if any of you know how that works, please let me know in the comments below, because the manual is not very useful on this section, but I think it has something to do with measuring or calculating battery internal resistance on your own. Maybe it will generate a set current pulse for a set period of time, but I'm not sure on that. So that's about everything you need to know about this interface. It's nothing fancy, it's very simple, and as I've said, if anyone is interested in writing a new app or translating this one, it would be a great addition, and it would make it so much more nicer to use this DummyLoad. And the last DummyLoad in today's lineup is this one, the ZPB30A1, and everything you need to know about this DummyLoad has already been discussed in other videos of mine, and I will link those in the description below. There is a review video, a reverse engineering video, and a mod video where I hacked this DummyLoad to work on a different range. I will just go over some of the specs. It has 12 volts DC power input through DC jack. It's digitally controlled. A discharge voltage between 1 and 30 volts, adjustable in 100 millivolts increments. The discharge current can be between 0.2 amps and up to 9.99 amps, adjustable in 10 milliamps increments with a 60 watts discharge power limit. But I think you can also get this one rated another model which is a bit more expensive, rated for 100 or 110 watts, something like that, which obviously has a bigger heatsink, bigger cooling fan, and the software adjusted for that. The fan is temperature controlled. We have a thermistor on the heatsink, and same as with the other digital dummy loads, it has a bunch of error detection features. As you know, I hacked this dummy load in a Voltlog episode 41 and changed its range from 20 milliamps up to 999 milliamps by replacing the shunt resistor with a different value one. Because that's what I needed back then. I needed to go down below 100 milliamps for testing batteries at low discharge currents. Clearly, it's the most expensive out of the models we reviewed today at $20 a piece, but it also has the most features and the most extended testing range. Another advantage is that the temperature controlled cooling fan is really nice, and it ramps up the RPM as the temperature increases. And the fact that it has a thermistor, it also helped implementing an over temperature protection, and it does come with a fan and heatsink included with the correct size for its power rating, so there is no risk of damaging this thing by overheating. So to wrap this up and give you my thoughts, out of the bunch, this one, the eLoad with the serial interface and PC app, seems to have the best set of features, but it does come with its limitation: maximum 15 volts and maximum 3 amps, limited to 20 watts of dissipated power. And I believe there's nothing you can do about that. Even with an increased heatsink and cooling fan, you can't go over 20 watts because it's limited in software. Once again, aimed at discharging small lithium batteries, but great value for money because of that serial interface and the PC app, which allows you to graph the discharge of these batteries. Second best, the one that has nice features but also higher power capability, is the ZPB30A1, which can go up to 30 volts, 10 amps and up to 60 watts dissipated power. This one has temperature protection, which is nice, but lacks the serial interface for logging and doing graphs. As shown in my review video, it does have a serial pin header on the side of the board, but you don't get too much info, and you don't have any PC app to log that. All the others lack some features that I like and are only present on the more expensive models, but they are still usable. They're just designed to do a more specific job with less features. It's up to you to decide if you need the extra features or not. So thank you for watching this video. If you haven't subscribed to my channel, now is a good time to do so. Don't forget that liking the video helps me a lot. I consider that feedback for my viewers, and it also helps with YouTube by positioning my videos better in searches and suggestions. I will see you next time.